Good afternoon, everybody. So I think I've got a slightly more positive angle than Andy had, hopefully. Um, at Nominate, we've obviously been running DNSSEC for quite a few years. We've signed the .uk zone quite a long time ago now. What I wanted to do, first of all, is just give you a bit of a DNSSEC primer, or probably there's a fair amount of people in the room who've not deployed DNSSEC. That would be quite interesting, actually. How many people in the room have deployed DNSSEC either at the auth zone for signing zones or for doing on the recursive side? Can you put your hands up if you've actually done DNSSEC? So not many, even in a room full of geeks, right? So one of the reasons we did what we did with DNSSEC over the last few years is try and make it simpler. So one of the reasons I think that people don't deploy it is because the combination of it not being seen as needed and having a real business case, along with it being complex and difficult to manage. So for those who might not have come across DNSSEC before, basically it's public-private key format in DNS, where you publish public keys in the zone. You use private keys for signing, for adding signatures into the zone. Obviously, the private keys need to be fairly well protected. Rapidly updated zones, such as the ones we run, like .uk and .co.uk, etc., they need constant signing, because every time we update the zone, it needs re-signing. And if signing breaks, then obviously updates stop. And that causes us a big problem, because people expect to be able to push changes into .uk and them be available fairly quickly. And obviously other implications around signing breaking, like signatures have got a lifetime on them, which means if it's broken for X amount of days, then they become not able to validate anymore. So for those reasons, DNSSEC, particularly at Nominate, is classed as a critical top-tier service. So we have all of our services at Nominate are kind of broken down into tiers to how critical they are. And the only things really that have top-level tier 1 are DNS and DNSSEC. So that said, I wanted to give you a kind of DNSSEC at Nominate, a kind of potted history. So we originally deployed the infrastructure to do DNSSEC in 2008. So it's like, 11 years ago now. We signed .uk back in 2009. Some of you may remember, that have been around a long time, that we had a fairly major issue with our DNSSEC implementation back in 2000. I think it was late 2010, early 2011. I don't remember the exact date, to be honest with you. I've tried to banish this from my mind. So we had an issue where we failed over we had a bit of hardware that failed, and because of that we failed over between one device and another device in two different data centers. And the result of that was we accidentally started signing the zone with a key that hadn't been pre-published, and therefore caused validation issues. Not many people validated in those days, so it wasn't a massive issue, but it was fairly embarrassing. The little picture there you can see is something that I get reminded about this incident every year on Facebook, because my wife kindly posted this picture and caption. If you can't see the caption, it says, helping Daddy to fix the internet, or some such thing. And that's my less than 1-year-old daughter sat on my knee while I was trying to fix this DNSSEC issue. So continuing with the history, we changed our infrastructure in 2013 for something else because of the issues we'd seen previously on the infrastructure. I'll talk about how we were actually doing this in a slide or two. So we changed the infrastructure in 2013. In 2014, we started our road to managing lots of GTLDs as well as .uk. And we originally signed those GTLDs with the old DNSSEC infrastructure, but in 2016 we simplified things to make things a lot easier to manage, and that's basically the gist of this talk. So if I go back to 2009, what we were doing originally, we were using some Sun SCA 6000 hardware security modules. So these were PCI cards that slotted into a server. These were fairly standard HP servers running CentOS 5, and like I said, these Sun PCI-based HSMs. And then for the software side of it, we're using OpenDNSSEC to do the automation of the signing. And that was, OpenDNSSEC was fairly new at that point, so, and we did find that we had reliability issues fairly soon after we'd started to productionize this lot. As usual, none of these issues appeared when we were testing, and all of them appeared afterwards. We had sites in Oxford and Kent, so our production site was in Oxford and a failover site in Kent. And when we had a failure in of the primary server, well, the HSM actually, not the server itself, the HSM failed in Oxford in 2011. That's when we failed over to the one in Kent, but the failover procedure wasn't executed properly, which meant we started using a key before we pre-published it. So that kind of introduced a lot of doubt around the reliability of the SCA 6000. We were kind of thinking for a while we'd need to replace them with something else, really. That was compounded by the fact that Oracle took over Sun and hiked the price up considerably. So these SCA 6000 went from, I think overnight went from £1,000 to about £20,000 each. I think Oracle just decided they didn't want to do them anymore, so we were going to put everybody off buying them. Obviously, the other issue we had here was support was split between two companies. So we were running the Sun/Oracle HSMs supported by them, and OpenDNS supported by somebody else. Brilliant support from both companies, but always an opportunity for finger pointing, and finger pointing did happen. So in 2013, we moved to our second iteration of DNSSEC. After looking at what was available on the market, at this point we were still focused on using HSMs as a lot of the DNS industry was at this time. Everybody was using HSMs. We must use HSMs. The keys must have that level of protection. And so we looked at what was available in the marketplace, and we deployed some Thales network-based HSMs. So these were kind of black boxes you put in a rack. They're 1U, look like a server, but they're all black, look with pretty buttons on them, and basically they've got a HSM built into them to protect the key material. When you want to sign something, you send it over to the network to the HSM, it signs it and sends it back again. Again, we had two of these in two different locations, one in Slough and one in West London. By this time, we'd got rid of our data centre in Kent. These were very reliable, but very complex to operate and difficult to support. So the problem that we had was that we'd set them up, they'd run for ages and never have a problem. When they did ever have a problem, it was very complicated to support them and get them back on the rails again. Again, support was split between two companies. Brilliant support from both companies. The only issue really was that very few people were using this Thales HSM for DNSSEC. It was usually used in banks for PKI infrastructures, and so that Thales were difficult to engage from a DNSSEC point of view. So in 2016, we moved to our third iteration, and what is currently still operating. We, along with I think quite a few other people in the DNS industry, we've moved away from using a HSM because we think we can offer the level of protection needed, enough protection needed without using a HSM, and hence get rid of some of the complexity. I think some people in the DNS industry still use HSMs, and certainly the root zone is still signed using HSMs, but I think different layers, the HSM, providing there's enough security, HSM is not required. So we now do all our DNS signing is done on a geographically replicated virtual machine. So we've got a virtual machine running in one of our data centers, and that's replicated to another data center. We use a standard installation of Bind. Obviously, this is supported by one company, ISC. We have a support contract. We've had issues. We've had them fix them. So that works really, really well. The private keys now, instead of being stored on a HSM, they're stored on an encrypted partition on the virtual machine. That encrypted partition is protected by a split password. What I mean by split password is it's a long complex password, The operations team, i.e. the team in that I manage, have half of that password, and then we have a group of security officers, which is a completely separate set of people. They've got the other half of the password. None of those teams ever get to know what the other half of the password is, and so whenever a password operation needs to happen on that machine, which is always at boot, but we don't reboot them very often. It's always whenever that happens, the two teams need to come together basically and put each half of their password in. Access to that machine is by a zone transfer for DNS, and that's all basically. It has no other network interaction other than zone transfers in, sign the zone transfer out. SSH is turned off by default. If any management needs to happen on the machine, that's done via the VMware console login, which again is protected by the same split password. Whenever we do changes on those boxes, they go through our standard change process, and so the engineer has to have a full plan of exactly what they're doing, and then him and the security officer come together. The security officer monitors everything that happens during that change. So this moves us to 2018, where my daughter has grown up quite a lot more since then, and I'm looking a lot less stressed than I did back in 2011. Happy to answer any questions. Or I'm here for the break if you want to talk to me afterwards.
Pete Taphouse from Lunup. How big are each of the two teams with the split passwords? And is there like a copy in a safe locked in a toilet downstairs? So, beware of the Jaguar or equivalent.
We do have copies of the passwords stored in a safe in a bank, so that if we're all destroyed, the passwords are available.
Cool, thanks.
Okay.
Okay, thanks, Brett.
We'll be back to you.